Okay, expanding, condensing, using your log properties. Okay, you got 3 log properties. What are they?
Addition, subtraction.
Addition goes with product.
Oh, yeah.
Quotient is
Division.
division, so you subtract.
And then exponents are
Power, you multiply. Okay? Alright. So, using this, let's expand this into multiple logarithms. Okay? Thoughts?
Well, you're going to do the top and then subtract the bottom, and then you're going to add the top together.
Okay? So, these two, when you separate it, will be separated by an addition symbol. And then this one will have a subtraction symbol in front of it, right? Okay? So, natural log of x to the 6th plus the natural log of the 5th root of y squared minus the natural log of z to the 3rd. Does that make sense? What we've done so far?
Yeah.
Okay? And some of you might go straight to the answer, that's fine. Okay? We used the product rule between those two, and then we used the quotient rule for that last one, the one on the bottom. I would like you to then use the power rule to move exponents out to the front.
Would the 5 in the radical, would that maybe 2/5?
The 5th root of y squared is y raised to what power? 2/5. Yep, 2/5. Because if you remember, the square root is like the 1/2 power. A cube root would be a 1/3 power. A 5th root would be a 1/5 power, but then you also have it raised to the 2nd. So it's like 1/5 to the 2nd, okay? Power raised to a power. So 1/5 times 2, you multiply those powers together, you get 2/5, right? So plus 2/5 natural log y minus 3 natural log z. And that's what I'm looking for there.
Did you give us worksheets for this?
I believe so, yeah. Yep. Okay, any questions on that? Drew?
I'm just curious, like, is there somewhere where we would see this, like, in real life, like, in work?
Honestly, I don't know where you'd ever want to very often expand logarithms. It's really just more practicing knowing the properties. However, knowing those properties becomes important in solving the equations like we did at the beginning. So without the properties, it's tough to solve equations that can be applied to different things in exponential growth and decay stuff. So all this really is just rote practice to know your properties. I can't think of anything where I've expanded it before to help me, but
Maybe just to see it.
yeah. So, Chelsea, okay on that?
Yeah.
All right. Other way around. This one you definitely probably use more often because if you have multiple logarithms in some sort of an equation, it is very helpful to write it as a single logarithm, especially if you're solving some sort of equation. Okay. In the previous problem, I did the adding and subtracting stuff first, and then the powers second. When you're working backwards, I do the powers first, and then do the adding and subtracting stuff, or multiplying, dividing stuff second. So I'd move all your powers to begin with. Okay. There's a very common mistake made on this problem. Where people write it much more complicated than they need to. So, how would you guys go about it from here? There's going to be some division, right?
Could you put X?
Could you multiply like the first one?
Minus a third and then that over.
That's right, but it's complex.
Like, could you
It's a
go?
little complicated. You don't need to do that. What Drew said is he's going to put x to the fourth over y to the third, and then put that fraction over z to the eighth. You don't need to write it that complicated. All right? That's not wrong, but I want you to simplify it to where I'm going with it eventually.
Could you go x to the fourth multiply z to the eighth over y to the third?
Subtraction, so is it like 1 over all those?
No. Let me go slowly through it, okay? Step by step, and I think you'll see where.
Is it z to the 8th over x?
Nope. Nope. Let's just do these two right here. Let's put those two together. What do you get?
Log x to the fourth over y.
Yep. Everybody agrees? If I put those two together, that's what I get? Okay? Because with subtraction, you have division going on. Okay? And now, Drew was not wrong. What he said was correct. Okay? So, yeah, you got another subtraction. So you have this fraction divided by that. Okay? Well, let's think about fractions here just a little bit. Okay? What's 1/3 divided by 4?
4/3.
1/12. Because really, 1/3 divided by 4 is like 1/3 times 1/4, and you get just 1/12, right? Right? What's 2/7 divided by 3? 2 over 21, right? Because really, you have 2/7 times 1/3, which would be 2 over 21. So if you look closely here, when you have a fraction divided by something, where does that something just end up going? On the bottom. So my final answer is simply log x to the fourth over y to the third z to the eighth. They're both on the bottom. Because when you take x to the fourth over y to the third and you divide it by z to the eighth, divided by z to the eighth, you're really just multiplying it by 1 over z to the eighth, aren't you? You guys follow that?
Yeah.
I'm really, when I'm dividing a fraction by z to the eighth, I'm really multiplying it by 1 over z to the eighth, and that just goes on the bottom.
You said multiply by the reciprocal, so technically if you were to do that.
You guys were on the right track, you just didn't write it as simple as it could. Okay? Any questions on that? Chelsea, better on expanding, condensing? Anything else I can address on expanding or condensing right now? Okay?